To today's webinar. We'll be talking about leveraging NX CAD within your design process. My name is Mike Senedak, and I'll be presenting today. So as far as our agenda for the next 60 minutes or so, we'll start out with a brief intro about CamLogic, and we'll focus our time on where design meets tomorrow using the NX product line. And we'll close out with a customer success. We'll talk about how we can help you gain a competitive advantage using NX. And then also just how you can get started with a special promo for today's webinar and any Q&A that we haven't covered while the session was going. So as far as Q&A, if you do have questions, please use the chat. Go ahead and put those in. We'll be tracking those and covering those as we go. Just note that we will be recording the session, so if you do not want to be recorded or your information show up, you can disconnect at this time and come back on at a later time. Watch the recording that will be on the CamLogic website. So with this, I'd like to turn it over to Rob, and he'll give you the introduction on CamLogic.
Hey, Mike, thank you very much. And everybody, appreciate you, everybody hopping on today. My name's Rob Stepek. I'm a relationship manager here at CamLogic. And I see a lot of familiar faces on the call. I see some new faces on the call. So just wanted to give a quick introduction to CamLogic, who we are, how we help our customers. So CamLogic, when it comes to being the manufacturing partner for our customers, we really take what we call a holistic engineering approach to supporting our customers. So we sell and service, obviously, the Siemens product portfolio. We have some excellent NX application engineers as well as trainers on staff. We're a resource for you. We want you to be successful with all things NX and everything within the Siemens product portfolio. So the Solid Edge, CAD, CAM, data management, simulation, technomatics, the whole 9 yards. That's really what CamLogic was built on. We have over 20 plus years in the Siemens product portfolio. And again, today is supposed to be educational. It's supposed to shine some light on NX and where it fits into production. I think that there are a lot of preconceived notions when it comes to NX with regards to different versions, different capabilities, different costs, all that good stuff. So we're an NX resource for you, and hopefully today is educational. Everybody takes away a little bit of knowledge from today. Beyond that, CamLogic is also a additive manufacturing partner of Markforged, and we also do a lot of scanning services, whether it be quality control or reverse engineering. So we don't necessarily help our customers with, say, the product development phase of manufacturing or production or quality control. We have the ability to touch in all sorts of different areas of manufacturing. Now, CamLogic as a company about 4 years ago said, hey, we have all this knowledge on staff. We have a bunch of people who work at CamLogic that have experience from cold forming to injection molding to additive manufacturing. How do we bring all this together to provide our customers with a really great offering for a solution partner? So we started branching out and have also been doing work on another part of the business as a manufacturer. We leverage additive platforms as well as traditional manufacturing in order to deliver everything from prototypes to automation components to tooling, fixtures, jigs, all that good stuff to our customers. And what really sets CamLogic apart and why a lot of our customers really look to us as an advisor is because we don't necessarily say, here's a case study from NX and you should be able to do this, or yeah, you can use NX quality control and here's the brochure and yeah, you should be able to do it. We use these tools in-house every day to be successful. So if you have challenges manufacturing wise, if you have questions about NX, if you have questions about anything within production, we can help you again across the board because we don't just talk the talk, we walk the walk here at CamLogic. So again, really appreciate everybody's time. This is going to be very educational for everyone. Mike is a wealth of knowledge when it comes to NX. We're really happy to have him today. And again, thank you everybody for your time. And Mike, with that, I'll give it back to you and we'll let you take it from here, sir.
Great. Appreciate it, Rob. Thank you very much. So yes, glad to have everyone here today, and really want to focus in on using the foundation of NX. So really talk to you about how our tools are in place and at a lot of OEMs, but a lot of suppliers and every size of company in between. And so, the thing about NX, it's part of our accelerator portfolio, and it is our flagship mechanical CAD product. And as you can see by the wheel, it handles all of the mechanical design type things that you would normally be, you know, working on and bringing to market. But also, it is a multidiscipline platform, so it also includes areas for bridging the gap with the electrical design, some things very specific for process design, and also on the automation for machinery design, plant factory design, those types of things. But today we're really focused around just how you can use NX and be, the most productive modeling environment on the marketplace. And so, out of all of those pie slices, we're really focused in on the product design and using the fundamental bundle because we are packaged in bundles, and so that's what we wanted to go through today and show you. And as I mentioned, please, if you have questions, put them into the chat. Both Rob and I will monitor that and try to answer all your questions as we go today. But as we focus right around the product design, know that there is so much more that you can grow into, scale into. Just like Rob talked at the beginning there, we can help you out with all of those areas. But we're really starting out with the fundamental building blocks today. So, a couple key areas on the modeling side. As you would expect, you're going to be able to go through and sketch and do all those things, the features modeling and that type. But there's three areas we wanted to highlight for the Mach Designer bundle. And so some things with synchronous modeling, how that can help our customers. Also from the sheet metal design, some of the strengths that we have there for that process. And then in the surfacing, NX has a very strong surfacing package, and we can showcase really the fundamental pieces and where you can grow with that. So if we take a look at the synchronous modeling, a lot of people have different conceptions about that. What is it? Do I really need it? How does it impact us? And so the real benefit there is synchronous allows you to make changes and modifications to designs, and it isn't dependent upon the other features and other things that are in the history tree. And so it allows for us to make very quick modifications, not long rebuild times that you might run into with a traditional history tree. And then just, a lot of times there's features that you may have in that you have problems with. This will go right through that. So let's take a look at how that operates. So the example we're going to work on is something that you might have, as a supplier, you might have gotten data in. You didn't have the history tree to work from, but you have to go in and do some adjustments. Maybe like Rob said, prior to manufacturing, you need to put some stock or you need to make some changes to either blends or other details there and move that information around. And so with Synchronous, even without that history, you're able to go in and do things like with the move or the pull face and adjust those features on there so we can adapt and move that design around. So instead of having to spend that time to remodel everything, we can just take that information as is. And you can see with the face finder, it speeds that process along for our users. They can go in and get everything that's, offset or coaxial with very few clicks, and then change that design where maybe you had a sketch in an original design, but you didn't have the design intent to make the changes that you want in this model. And so that's where Synchronous really shines, is being able to make those adaptions of the geometry. And as you'll see in the history navigator on the left, once you complete those, now you actually have history as a part of the model. So with this, we can also put things like localized dimensions. So whether you put in the linear dimensions, radial dimensions, you can put those in. And the face finders allow us, again, make use of symmetry, other things like that to speed that process along for your designers. So when we talk about, that productivity, it's these types of tools that help our users speed that process along. So we're not going back and remodeling. We're not having to patch in geometry and then cut it out. You can just go in and make those changes. So just like we did on the, whether it's be the linear or the radial dimensions, you can see that it inquires about the geometry and puts that into the dialog. So even there, you can use it as a quick check. Also, things like your geometric constraints, you can go in and, whether it's coplanar, tangent, all those types of things, you can build those into the model as well. Some places where this comes into play and helps out is even for if you're preparing models for manufacturing. So some of the offsets in that to the geometry. Also for simulation, you can go in and delete faces and simplify and idealize the model down. So there are a bunch of very good tools for that model preparation for those next applications or downstream applications. Also, some things here, like with the replace face, it speeds the user for, in this case, this is an arrow example, but even in a body and white example, you might have geometry built inside that shape and design changes come, new surfaces come in, and I want to change to that new skin or that new body and white to match with that. And so this will allow you to do that. You can go in and you can see, hey, if it's something that the user, hey, they didn't do right, those alerts pop up on the right hand side, give you keys or prompts to, hey, this is what you can do. So you can see with this that in a very quick manner, we can change that whole exterior surface. We're not having to get rid of geometry and re-put that in. And so, in a few minutes, we were able to go and build up some of those new features inside this particular model. So that's really the benefit of Synchronous is if you have history, it'll make fast updates over some certain areas where you might not have the design intent, or for bodies that come in from a OEM and you're working on them and you have no history, this allows you to make those changes. So the next step would be to take a look at sheet metal design. And this is an area where a lot of customers, they just use standard modeling features in other packages because it may not be strong enough or may not be able to develop the sheet metal parts. And so in NX, we have a very focused task environment, and it has some very robust coverage across all those types of features that you need to be able to generate, the sheet metal parts. But it's not just for the part, it's also for the downstream pieces. Automate the drafting of that information, be able to create your flat patterns quickly so that you can output that to manufacturing. So all of those things, we look at it as a holistic approach. So if we jump over to an example, one of the things with NX, we have a robust set of templates to start with. And so in that, you can start out with the sheet metal template, and what that drives is right into the application that you need. So as you develop this, it's based on the sketching environment. You're going to create whatever profile that you want to start from as your base feature, and then go through and use the commands to add the flanges and the louvers and the different bends and different things like that into the part. So, once you know how to use the sketching environment, that you're good to go as far as putting in the detail that you need. And, you know, then you really end up driving it with the global parameters. So once we have that initial shape, you can set your preferences, and that could either be by the material, the metal that you're going to use. You can also put in, material thickness and those types, your bend definition, all of that information. But the power here is if you modeled up the whole entire part and then came back and said, "Oh, we need a gauge, or we're changing the material for the part," just by changing those global parameters, that will update your entire design. Also here, what you'll see that I'm walking through is, as a user, I can go in and put, you know, definitive values in for length and angle and that, but you also have the drag handles. So as you're trying to see how does this match up, or how do we develop this, it gives you that real-time feedback, and that's what you're seeing. You always get the preview of what's going to happen. So it doesn't just wait until you fill out the dialogue and then generate something. You're always getting that real-time feedback for your users. So that way they don't have to guess what's going to happen. We'll know up front. And what you'll see is when you're working through any of the dialogues in NX, one of the big things is that, anywhere where you see the red asterisk, those are things that have to be entered in order to complete it. So just like you do on a website, you have to put in, name, address, those kinds of things. It's kind of the same concept. And once you've completed them, you see the little check marks there for the user. So they understand the visual cues as they're walking through it. And as you continue to work through, you'll see certain things for bends. So for putting in different flanges, different types, those are available. Also from the standpoint of you can do localized unbending, right? So if I need in this case to put a feature that goes across the bend, you can locally unbend it, put the feature, the cutout that you want in this case, and then rebend that section. And so all of that is part of your history there in the on the left hand side. So if you need to edit, you can just go back into the feature, or also at the bottom, there's just a details panel that you can expand, and you can make the value changes right there. So you don't even have to go all the way back into the menu. You can just change the parameters right at that level. So other things that come into play is if you have any drawn or punched type features, things like, little dimples, or you might have louvers and other shapes like that. Those are already out of the box. So you only need to use the sketcher to give it the profile, or in the case of the louver, you'll see we just need a single curve, and it uses all of that information. So again, all you have to do from a user standpoint, select, fill out the dialog, couple selections, and you're ready to go. You'll also see that there are many options available. So not only is it, say in this case, a lanced louver, but you also can go in with the formed. So all of those are ready to go with you. Um, Also things like the gusset, right? So instead of having to model up all of that geometry and have difficulty maybe creating that, you can just go in. It just needs a location and the dimensional sizes that you want, and you're ready to go. And so that takes care of everything that you need. And so also then you'll see on the backside is for manufacturing, how do we create that flat pattern? So it takes into account all of these features that we're putting in. And so it's as simple as that, using the drag handles, putting in the values, and you see the user has those commands right at their fingertips. Also, things that you might be doing as you're working is if you're new to the system, we have in the upper right hand side the command finder. So if you know, hey, I've used brand X and I need to find something, type it in. That'll bring you and generate a list, and it'll go ahead and you can start the command from there, or you can see where it is on the ribbon bar. So easy ways to get started. Also, with the welcome page that you see the tab there, it will go ahead and take you into some initial tutorials as well. So we mentioned about the manufacturing side, you know, one touch generation of the flat pattern, one selection for exporting that 2D geometry out. And the power of the flat pattern is it also automatically annotates that. So you saw there were the bend angles and the information. And so now when we use one of our drawing templates, we can use the master model to take that digital twin, put that into our drawing. So there are tools here to automate the title block. There are things that particular 2D flat pattern that we created, it goes ahead and drops that in. We also have the bend tables, so you can automatically generate those. So again, one selection for the user, and you move through that process. But also it's kind of nice to be able to have, other 3D views on here as well. So you can go in and add any of that, have all of that together. And from here, if you need to share that to the shop floor or you want to use that information to your customer, you can also go ahead and output that to a PDF format. So you can share that readily with other people and they can use that. And then the other piece is, that design change happens. You want to make sure that that's as easy as possible and that it's communicated appropriately downstream. So as you'll notice in the drafting side, it lets the user know, hey, this is out of date. They also can visually see from the part navigator, hey, these things need updated. It's a one button push. Everything's taken care of. You're ready to go. So it's just that I wanted to show a little bit of a process based with the sheet metal. Here's how you design it. Here's how you can go through and document it. And here's how you can push it to manufacturing. And in many things within the NX environment, that's how we're built or how we're structured, is to really do the industry best practice. How do we build that in and use that? So another one that is important as we talk about it is the surfacing. So there's a lot of times, how do we build or develop that geometry? And so that is an area of strength for NX. So we have it as a scalable type tool. So there are some basic things that you can do. I know that Rob had mentioned, hey, you might get parts in that you get from reverse engineering, and you have to go in and start to create surfaces in that. You have some of that base capability to be able to surface the model. And the power with NX is that hybrid environment. We're able to use the information, whether it's the sketching, the 2D information, the 2D and 3D splines, the surface geometry, all of that can go into one system, as well as things like your STL files, so faceted geometry. All of that can be used inside the NX environment. And here with the surfacing is really about being able to use the information from the surfacing and your more industrial design type things along with your mechanical design. So in this particular case for the RC helicopter, we're going to create that new case that goes around the motor and the battery pack and those things. And so you don't want to have to switch tools. You don't want to have to translate data. You don't have to do that with NX. You just stay within the system to develop that. And that also ultimately leads to easier design changes, making sure everything's correct, because we're not having to translate or copy data and do all kinds of things like that. So let's take a look at, just how did we get there, right? So this is just an example of, hey, we're working in the context of the assembly and being able to go in and use the information. So in this case, inside of NX, you can read in, raster images like a TIFF file. So if somebody had marked up the napkin type sketch, you can read that information into NX and use that as a guideline to help us in developing this. So you can do that with the hybrid environment is a combination. In this case, we're just doing the 2D splines. So you can select, the plane, you can select where we want to work and lay that information out as our, guide and cross strings. You also can use the sketcher. So if you want more control over that, that's what I've done on the tail boom is I've actually created the sketch ahead of time. Is you could go in there and create, construction geometry and splines and put dimensions and things like that. So it allows you the flexibility to do both, right? If I need more control, I put that into my design. If I need less and I'm doing it more as a free form type design, I can do that as well. And so things like, yes, most people say, okay, you could take the curves and extrude those, but it's also the things for sweeping the geometry, and then things like the through curve mesh. Those are powerful in developing those curves and lofting the surfaces through that. And so what that allows us to do is not only create the geometry, but to control the continuity. So as you're working, you may do things where, hey, we want to make sure that that surface is, tangent to the other surfaces. Make sure that you have good surface quality in that. And so that's definitely doable. And you'll see as we work through, those things are built into the menus. Also, things like 3D splines, right? As you go in and generate those, you can basically, like in this, create the beginning and ending, and then along that spline, we can add all the points that we want. In this case, I only needed one additional to help me adjust the shape that I want, but you can put multiple locations and control those. And so here with the through curve mesh, you can see that, we're using the front curve. It's using the point location as well as then the curve on the backside. And then as we add the additional cross strings, you get that real-time feedback. So right away, the designer knows, hey, is this what I expect? As we talked about the alerts, if there's something that I'm missing, the system will try to prompt you and help you through that process. And then also, as I'm learning the system, you'll see as you roll over those particular areas, you also get feedback. What is it expecting? What does it want? What does the system need from you? And so this is where we're talking about, keeping that continuity, the tangency, all of those types of connectivity to the other geometry so that you get a good surface out of it. And so, again, as you're working through this, we're intending to head down the plastic part route. So it's just giving you that flexibility to put in the geometry that you need. And in this case, just some additional 2D, we're gonna do the capping on both ends of that. So how easy is that to do, right? So you're just going in, the ability to trim the surfaces, to add to the surfaces, all of that is built in right out of the foundation, right? So again, when we talk about the packaging, this is the base package of NX that you can accomplish these things. So as you work through, many times you want to take advantage of symmetry. You don't want to have to do things twice. So that's what we've done with this design. You also have ways of controlling the geometry, what you want to see. So the show and hide is good. If you like layer settings, that's also possible in NX so that you could put, all the sketches on the layers in the 20s. You could put all your datums in different layers as well. So we support, both ways with that. So in here, you just see a little bit about, again, capping it off. If you have something that's more contoured, we have that ability with the end-sided surface. If you have something that's planar, you can just do the bounded plane to close that off. And so many times as you're going through that process, you may want to turn it into a solid. You can do that. You can sew that together, or you can continue to use those surfaces and trim away other solids. It just depends on what your end goal is. Um, that's where the hybrid modeling shines. You can do any and all of that as you work through. So just a short way to get through that. And you can see here, this is what we were focused on initially. Now, where I would go with this, if we were doing more just this particular development is, then we would show you in the next section how you would geometry link that body out and use that then to create your plastic part. But wanted you to see some of the surfacing capability. And again, that's not all that we have. That's just scratching the surface of the capabilities there. So another area that a lot of customers, are really interested in and really how can you use NX to gain that competitive advantage is assembly performance. Machines are getting more powerful, but designs are getting more complicated. So everybody gets larger and larger designs. How fast can I load that information? Also things about reuse, right? I don't want to keep reintroducing new parts, new geometry and things if I have things that I can reuse, and that can be 2D sketches that are always used in a particular starting point of our design, or it could be 3D geometry. It might be something that we use on, this particular little pump, or standard parts, right? So NX provides a free NX machinery library that comes with the tool. So anything that you have in the machinist handbook, we have all those libraries ready to go as a free tool, and things like making use of those with fastener assemblies. So we'll show you a little bit about that. And then the last piece is really the geometry linking. How does that help speed the process along and help drive change across multiple components? So when we talk about the assembly performance, we've invested a lot in and around the minimal loading. So we want to make that as fast as possible, right? Optimize the way that we load those files. And also, just because you're getting more hardware capability, we don't want to use all of that up. We want to reduce that memory size. We want to take advantage of some of the multi-threading that the computers can do. So all of that has gone into making this seamless to the user. There's not a lot of hoops, a lot of switches, a lot of things that you have to do. It just works that way as you work through. And so you can see the different examples, and I have just, the number of components and the load time, and we'll go through the largest one, the one that's almost 23,000. But in each of these cases, it's under a minute that we can load these types of files. And so, one question I get sometimes is, how come the aircraft takes longer than the marine example on the left, even though the marine example is more components? The issue there is, what is the complexity of the geometry too, right? If I have a bunch of primitive type shapes versus now I have more freeform, more complicated designs, those all factor into it as well. But let's take a look at how this works with the truck. So the heavy equipment here on the load options, by default, minimally load is on by default. I just wanted you to be aware of where that's at, how you can access that. But literally by us selecting the file and going through, what you'll notice is the bill of material on the left comes right up. So you see and know what are those files. And then it starts to graphically show you what's there. So instead of it waiting to load everything into memory and then repainting, you can get that feedback right away. And then also you'll see in the middle of the dialogue, the pause and play. So if I've got enough information, I can pause, look at where I'm going and make some changes, or I can stop. If I have enough, I don't need to load the rest of it. I could actually stop that process as well. So from there, you see, okay, we can see it on the screen. And so a lot of people will say, well, okay, that's great, but what can you do with it? Can you do anything with it in this minimally loaded state? And the answer is yes, we can, constrain other parts to it. We can switch between parts as we design. In this case, where we're working, we can actually go ahead and section through the model if we want to see. And this is just in this case to show you a lot of the detail, but when we sectioned and rotated, it didn't bring the system to its knees. You're able to work with that. So the other thing is, as I mentioned, as a user, once I find what I need, I can easily locate that within the bill of material and then work in the context of the assembly. So even in this minimally loaded state, the system knows, hey, Mike wants to work on, the fuel cap. As soon as I select that and say I'm going to make that my work part and begin doing some of my design, the system, and not that you have to worry about it, but the system is automatically, that's what it's showing. The feather is the lightweight and the diamond is the full model that now I can change parameters, I can do those things and update the model from there. And again, as a user, all I'm worried about is get to the part, do my work. I'm not having to worry about, do I have the memory? Am I doing the right things? The system is handling all of that, behind the scenes for us. So that's the power of, the large assemblies in NX. And this is not, obviously not the largest assembly that we get, but everybody has a different thought on what's large to you. Could be a couple hundred parts might be large to you at your company, and somebody else it could be 100,000 components is, and we really handle all of that from smallest to largest. So the other area that we wanted to talk about was the reuse library. So as we get into the reuse library, it's a central location that all of your designers can point to. And so that is, it can be the 2D geometry. We have some things out of the box that you can use, as well as it's very easy to capture what you're creating on the screen and put it into the library. It can be 3D geometry. It in the drafting side, we have drafting symbols in that are out of the box, as well as ones you can create, and then the standard parts like we talked about. So that free machinery library, you can have that ready to go. It covers many standards, ANSI, ISO, DIN, and more. And these are easy to drag and drop, as you'll see in our demo. And then again, if you want to create them on the fly, you've created something, you can do that, put it into the reuse. All your designers can have access to that. So in this machinery example, where we wanted to go was, many times you've created some parts and you're going to bolt them together. You're going to do some kind of connection between them. And so many times you'll have created the part, you'll have put the holes in, built the bolt circle and things like that. Well, one of the ways we do to help speed that process along is here, if you look at the machinery library, if we're using the ANSI standard, we can drop in any of those fasteners or any of the other parts. And one of the things that we can do is, because it's knowledge enabled inside the menu, We can set the sizes, so it's using our family of parts. And then also you can do your patterning and pocketing all at one step. So you still have the ability to go in and put the holes and then just drop the fasteners in. But in this case, I'm having it drop the fastener and create all the holes for me in one shot. So speeding the process, making sure we have the proper alignment, all of those things that we need, really from one method right out of the library. So again, you have that option and flexibility, but just trying to show how are we thinking about making the user more productive? How are we giving you guys the best environment to do your job and get the job done quickly and correctly, right? You can go fast and still make a lot of mistakes, but we want to make sure that you're doing it correctly. And so as we drill down to the parts, you can see, hey, these are all connected. Here's the geometry that's to that. So if you change the pattern, if you remove or you add some more, all of that geometry is going to update there. So this is just showing, a little bit of that process, how that goes through. So as we mentioned, the reuse library is something that everyone can use and point to and be able to take that, over and over again, so that you're putting best practices into the library. All of your designers are working from that. The other one that makes use of this as well, this kind of shows the other method. Hey, we've already got a pattern set of bolts on there, bolt holes on there, but we want to go in and fasten this. So normally you might go through and say, hey, I've got to build up that bolt stack and put that in. Well, in this case, you can take the fastener assemblies that we have, use those, or you can configure your own setup with that. And all it needs to know is the start and end face, but it puts together the right location, all of the components that need to go into that, and you're ready to go. And if you need to make changes, in this case, maybe they're too long when they first came through, you can just go right to the menu, the knowledge menu, and make the modification to that. So just some different ways to speed that process along with the reuse. So hopefully that gives you a good idea of some ways to bring that to bear for you as you build your designs and lay things out. And as you can see, right, as part of the bill of material, it's going to have all of the components. In this case, this is a small subassembly that gets added to that, and those are ready to go for you. So another one under the assemblies is geometry linking. So this comes into play when you're trying to, it could be something where you have a cast part and you're working on the finished part and you want to share some of that information between those parts. It could be for building weldments, right? So you might have, here's my stock pieces, then I move that into another part where I'm welding it together. It could be for your manufacturing stage models, right? Initially, we're going to drill these holes, we're going to mill this pocket, we're going to do these things. And so I don't want to have to keep creating from scratch over and over again with that. So that's a way to use that. And the key is, it's associative. It's associative through the design process and through your downstream operations. So with this, we'll use this automotive example, this connecting rod, but it is an assemblies process. So the way this works is you're able to put that into the system, open that up, and then what we'll do is we'll create the other assembly components underneath that. And the geometry linking allows us to, it could be the solid body, it could be the datum planes, it could be the sketches, whatever you think you need to go through that next step. And in this one, we developed the whole part, but obviously, on the connecting ring on the bottom, you usually have that cut in half, right? So that you bolt those sections together. But I wanted to make sure that the interface was right and everything's lined up. So we modeled the whole part, and then we'll actually use the geometry linking here that you see and associatively copy that into the other models. So instead of you doing a save as and then have two parts that aren't associative, using geometry linking, they actually are connected. So you can see that the history part there, the linked datum and the linked body, those I can go back to. These are good for even when you're working as a supplier. If you get a part from somebody, you can geometry link that and work on that part instead of the customer's original part. And that way, if changes happen, you can actually swap those geometry links. We can move it from one part to a different one. So very powerful method for working from, a top-down approach, being able to use that to drive your design. And so things like, the smart measurements and such, I'm doing this more just so that you could see the change when we go ahead and make the design change, but all of those values and expressions are in the system, right? So those associative dimensions, we can use those to operate on if we want to create formulas and other things to drive geometry. We can use all of that information. Also measurements for, if you're checking weight, center of gravity, all those types of things, those are available to you as well as you go through. So you can see as I went through with this, I had that initial one part, we've broken it into the two, but now I can go back and edit any of the features within that part. So this case, the bore, we went from 2 to 1.5. And you can see that simple. It drives that change through to both parts now, and you're good to go. We know everything's going to match and fit up properly, and we're not going to have any quality issues that, oh, I forgot to go change the other part, the drawing didn't update, all those things. With geometry linking, we know that that's going to work properly. So again, there's a number of ways to institute this and use it, but it's working with, assemblies in order to drive them. So another spot here is the simulation, right? So everybody wants to know, how do we get our designers to do more simulation? How do we move it earlier in the cycle? And so one of the ways is by helping, designers with a guided process. So in the Mach Designer and actually all of our Mach bundles, as a foundation, we have wizards built for stress and vibration. And so in there, it is a step-by-step process. So it takes some of that, concern over, hey, I'm not really an analyst. I don't really know all these things. But here it's guiding you through. So if you need to do a linear statics structural analysis on the part, you can run the wizard against that. Or if you would like to find out, for the modes of vibration, we can calculate the first 5 with that. And so the power in this is that, this then is scalable into our full SimCenter 3D suite. So once you create these files, they can be opened up into SimCenter 3D. Additional work can be done on them and such. But the key here is, for a designer, hey, I really only want to follow the key steps. What's the part? What are my loads that I want to put on there? So instead of having all these different load types, it's a subset for them. So it's very focused on the designer level to be able to go in and do that work. Also, things like units, right? How many times unit mistakes are done in traditional CAE? Here, they're set up for the user. Hey, I'm putting, you know, a Newton on, or I'm putting a pound force. Whatever you need to do, it's there, and you can set that up. Same thing with the constraints. Instead of having to have all these different choices, it's a smaller subset that you can go in and pick from. And you also have access to the full material library inside of the NX environment, so you can assign that. And then the meshing, right? A lot of times that's a critical step, getting a good mesh. Well, here you don't have to go through all those hoops. It's going to do the correct mesh. And then when you solve, we're using NX Nastrans, so you know that it's a proven solver. So the types of results and things that you're going to get out for structural and for vibration, they're going to be good. And that's really it. It's in a few steps, you've quickly gone through. And this is how we get this earlier in the cycle. How do we get users to walk through this? I think most anybody, if you see this process, I think most people would say, yeah, I could accomplish that with the product I'm designing or working on. And so, same thing with the results. Displacement's important, stress values, and then a factor of safety, right? So it'll look at the part and give you a color coded, hey, are there some red areas that we should be concerned with? And then ultimately you want to be able to report that out. So, Rob and I'd like to have a design review after we're done. Here's everything. It output everything we did for the design, how did we set up the loads and boundary conditions, what were the materials, and then all of your results, right? So you can see all of that and review that with the report. And that way, hey, if we need to do something later on, we can always come back and do that. So that's the power. And ultimately, when you finish, you're saving that information so that it can either, you can open it back up here or read it into SimCenter 3D. Those files are stored, and that sim file can be opened from there. So the other piece, I think that a lot of our customers, and whether you're an OEM or a supplier, it comes down to collaboration. How do we exchange this data and information? And so, whether you're trying to do 2D information, we have a good way of exchanging, AutoCAD, DXF, and DWG. You saw earlier with the sheet metal, we were outputting the flat pattern. If you create your drawings and you want to share it with PDF, you can output that. Some people still use IGES. I don't like it, but it's there. It's something that you can use, as well as 3D solids, right? So if you need step files, you can exchange that information between a lot of major CAD vendors. That's a good format to exchange, as well as opening native files like Solid Edge or SolidWorks. Because they're on the Parasolid kernel, we can open that information right up into NX as well. And then finally, we talked about facet modeling, but things like STL, the newer type with some of the 3D printing, OBJ. So those are ones that you can read in, export out from here. So all of those are covered, as well as, I'll say our two major standards. And this is where we talk about being an open system. Parasolid is our modeling kernel. Many tools, actually, we sell that to them as their foundation for CAD tools, CAM tools, that they develop their product right on top of that. The power there is then you can easily move the data between those systems using the Parasolid file. So that's something you could read in or export out. Other tools don't always tell you they can use that format, but they can. The other piece is JT, and maybe you've heard of this, but JT is our lightweight viewing file. So many times for users of Teamcenter, or some of our free viewing tools like JT to go, you could output that from NX and you could share that. That could be used on your shop floor. That could be sent to a customer. And again, you can use the free JT to go viewer to open that. They can do view and markup and different things like that with that format. So just some ways to share the information and go from there. So we've covered kind of the key things. I know we're getting down to about the last 10 minutes or so. Just to want to close out now, also catch some of the questions that we had in the chat. So just from a customer success standpoint, I think most of you know, especially being in the Detroit area, Michigan area, a lot of heavy automotive and manufacturing presence. So most people understand, oh yeah, GM or Daimler or Fiat Chrysler, or these guys use it. So yeah, you got to be a big company. And I would say that's partially true. We have a lot of large OEMs like that, but we do have a lot of startup companies as well, whether it be in the medical device, whether it be in aerospace, um, any of these industries, they're adopting NX. And why are they? Because they start out with something else and they get to a point where the tools just won't get the job done. It gets them 80% of the way and they can't finish the rest of the work that they're doing. So Zipline is a great example of a very small company. They were an innovator for medical delivery. And if you haven't heard this story, it's a great story of using these drones to deliver medical supplies, blood to very far off locations. The roads weren't very good to get the devices and get the life-saving medicine there. So they use these. And, this was one where they couldn't afford to fail, right? If you have to get blood to a certain location, you only have so much time. And they've seen their success rate, almost at 100%. So point being, yes, we have a lot of the large OEMs that use our tools, but there are a lot of companies like this. And if you want to look at some other ones, Unlimited Tomorrow is one with a They do prosthetics, and so they're bringing the cost down and helping their customers. So some things like that to help out. So what did we see today, right? We just scratched the surface. And I know you might say, well, how come we didn't show this or that? We were focused in on the Mach Designer bundle, which is the first layer that you could purchase, the first package level, and that focused in on a small area. We cover a lot with NX. We could spend hours sitting going through all those pieces, but we wanted to show you that from a price point and from the tools and the functionality, you really could get started with NX. And so it gives you a growth path, and we can help you with all our investment in new technologies with generative design, the whole process for additive, right? We have from design to simulation to manufacturing. We can help you bring those things together with electromechanical, right? Bring those disciplines closer. We have a great leading edge data management and product lifecycle management with Team Center that you can connect to, as well as our simulation and manufacturing, NX CAM and SimCenter 3D. So with those, we feel that wherever you're ready to start, we can give you that advantage of a comprehensive digital twin starting with NX. We can do that in a very personalized, adaptable UI. And I think with our formats and the things that we do, we give you an open ecosystem to connect to other tools and how you can use.
I don't know if you have a little bit of time to field a couple of them
Yeah.
that may have
Yeah.
come in, but again, hats off, Mike. That was great. Thank you.
Well, thanks. I really appreciate everyone joining today. I see there were a couple comments and a couple quick questions. So, Farouk, I appreciate, I know I was going at warp speed, so I was trying to, keep everything together and try to get as much in front of you. But the synchronous modeling and sheet metal, appreciate the feedback there. The reuse library, same thing. Just it is and can be very helpful. It's one of those things that I'm sure that Rob and myself and that, a lot of times customers don't go and do the setup and do some of the things to really gain a huge amount of benefit. So that I appreciate that. Now, Jeff, you were asking about the licenses, so I would encourage you definitely to reach out to the sales at CamLogic about what it would cost for the 3 seats. Again, the promo I think will make it very palatable to help you do that. So yep, yeah, Jeff's laughing there, but and then your question about the PDM. So the main thing with the Mock Designer bundle is the difference between it and the next package up is the Team Center piece, so the Team Center connector. So with the one that we're talking today is just using the operating system to work with the software, but same thing with the CamLogic team in that, the next step up is to have that basic data management through the Team Center environment. And so that might be that next step up. But obviously with your requirements, that's what we'd like to see and have a further conversation with you about that.
Yeah, and we're 100% here to scope it out and make sure that we're getting you the resources in front of you to be successful. So again, another another notch in the yep, we're a resource for you. Ask us how we can support and we'll do the best we can for you.
Absolutely. Rob, I saw those were the ones towards the end here. I don't know if I didn't, scrolling up, I didn't see any beyond when we had started. So,
Yep.
you know, anything else that you saw or anything else we wanted to finish with?
No, I think if like I said, if anybody wants to type in some questions, we'll be happy to field them. Or if you like to reach out to CamLogic individually, we'd be happy to do that as well. I guess we can hang out for a couple of minutes. But again, great job, Mike. Thank you, and thank you everybody for hopping on today. We really appreciate it. Thank you.
Awesome. Yeah. Thanks a lot.
I guess there was a question about explaining the difference between Team Center versus OEM Team Center.
Okay. So I'm going to take a shot at that one. So Team Center itself, you know, anyone can get the Team Center. When we talk about OEMs like General Motors, Daimler, they have some specific requirements and pieces of the Team Center that they provide, and so usually we work with a partner to implement those and to drive those. So there are specific requirements for like a General Motors in order to work inside their Team Center. So many times you're not going to install Team Center at your site being a supplier. You'll actually just need the connector portion that will tie you into, say, a General Motors. I use that example because that's the one I'm most familiar with. But that's kind of the difference when you talk about it. It's still Team Center. Ultimately, Team Center is managing all the information. It's just where is it set up, and then how are you getting connected to that?
Thank you.
Mhm. Yeah, so as far as where does NX is sold globally, right? So Siemens Digital Industry Software, and our partner community is across the globe. So yes, I mean you can get the software. It can be across any of your locations worldwide. Okay. Well, it looks like we've reached the top of the hour, but again, if you have questions, please direct them to the CamLogic team. If there's some additional help that Kim or Rob need, they have my contact information, and I'd be happy to help you with any of your opportunities. So again, thank you so much for spending the hour with us. I hope that you found the information valuable and that it will help you make some of your decisions moving forward. So again, thank you, and have a great afternoon.